Hey everyone, welcome back to the lab. In this video, we're going to be talking about servers as factories, a simple metaphor for thinking and reasoning about software servers. So a good metaphor allows you to compress an idea such that you get a lot of leverage out of a little bit of information. Software can often be hard to reason about because it seems to live under different rules than we're used to, thus making it hard to intuit. And so when we're thinking about intuition, a lot of intuition is just like past experience and patterns we've seen as humans that we can think about. So an example of like an intuition is like, I've never tried to pick up a car. Based on all my experiences with cars, I can tell you that I probably can't pick up a car because it's heavy. Now, the problem with software is that like we interact with software in the form of like apps and websites and stuff, but like a lot of things of software aren't like physical. Like, they don't like, does gravity work on software? Like how heavy is software? Like these things that we see in everyday life don't really apply in the same ways. And so a lot of times when they're creating designs for software or something like that, we don't have the intuition built up from our everyday life like we would if we're working on something physical. And so in my years working as a software engineer, you can learn more about my career here, I've seen many odd software decisions and arguments and conclusions that don't seem right. And they seem to be built on false assumptions about how software works. And usually if there's a disagreement, I think in most of life, it's like because we're missing some shared context or some shared understanding, or maybe a core value is different. And so I found that like for most disagreements, what we need to do first is understand the core assumptions, values, arguments first, and then we can actually find out where the disagreement is. And so I've seen this a lot in software, in tech companies, things like that. And this is bad, but it can be very hard to course correct. And it's very hard to course correct sometimes because it's hard to explain why these decisions are wrong without that shared context on foundational assumptions. Because if we both have different assumptions, we're just going to run each other around in circles, missing the actual thing that's different, which is that assumption. And so in this post, we're going to explore a metaphor that I've been toying with for thinking and reasoning about software servers, in this case, factories. I think it works pretty well and can serve as a 3S, Simple Scalable System, we can build on for further explorations of software principles. And so in particular, the different kinds of things that I think this is very helpful with is like thinking of servers for like system design, especially like architectures and things like that. But then as we zoom into software, if you understand how software architectures work, how they fit into the grand scheme of things, then I think also your software system design within a server gets much better because you understand how they interact with, kind of all bounded contexts of different like. And so the question that I'm trying to solve in this video is, what is a good metaphor for thinking about software servers and their functions and constraints? And so in this post, we're exploring the metaphor of a server as a factory. It's a pretty minimal metaphor that has a lot of overlap across these domains, and thus I believe works well for exploring many different scenarios. And if you've been following me, I love these like kind of building games, and I think a lot of the building games I play, like Satisfactory or Mindustry, any kind of town building thing, any kind of factory building thing is basically programming. So I think this has quite a lot of overlap, and hopefully that's clear as we kind of get through the metaphor. Okay, so a server is a factory. In many ways, a server is just a digital factory. We need something done, so we build some infrastructure to do it efficiently. And so in its simplest form, a factory simply takes inputs and produces outputs. Servers running software are the same, just the inputs and outputs are usually virtual rather than physical. And so this might seem contrived, like whenever we kind of boil things down to like their basis, often we like miss out on a lot of things and intricacies and stuff. But I actually don't think that's true here. I think this really is what a factory is. If you have a factory that is not taking things in and producing things, then it's not a useful factory, shouldn't exist. Same with servers. If your server is not doing anything, it doesn't need to be online. And any kind of thing that's useful is taking something in and doing something to it and producing something else. That's what factories are for. That's what servers are for. We can even go further and say that's what functions and software is for. And so if your thing is not doing that, you should think about whether it's necessary or not. So this is it at its simplest form, but also in all forms, I believe. Okay, and so, a factory here might take in raw materials. It's going to use like workers or robots, whatever it is to fulfill the orders based on some set recipes. that it has. Maybe it's like producing nails or screws or something. So it gets like some metal ore and it turns that into like, I don't know how they make nails and screws, but they press it or do whatever they got to do. They got some recipes for that. And then they're going to like put it somewhere so that when the people come to pick it up, they can like give it to them. Server is basically the same, right? Like it's going to take in data and it's going to, do whatever calculations, things that it needs to do. Threads are the things that are like actually going to take the instruction sets, your program, and actually like do the work. And basically all it's doing is taking data and calculating things, processing things to create new data based on your program. And then you're going to put that data somewhere and schedule it for delivery. Basically the same. And so we most often enlist factories when we need to do things at scale. Some factories make raw materials, others use those materials to create more complex items. Obviously this is recursive. You can take more items and make more items. And still others just organize those items for later distribution, like a warehouse for Amazon for like on-demand delivery or something like that. And now servers are very similar. Like if we can do something by hand, we usually don't build software to do that thing. So we really are using this to scale. But we want to scale a process beyond what humans can do, then we may opt for coding it. And so now, similarly, some servers just make raw data. So this could be like a time server that we use for the internet. Is this raw data? No, there's still some data, but like this is probably the most raw you can get is like, this is the time everybody used that. Others will fetch data from multiple places and process it into different derived data. This is what most software and apps do. This is why we use it. It's really good at it. And like most apps are CRUD, which is create, read, update, delete. All that's doing is taking data, doing something to it, and storing it and turning it into different data. That's all it's doing. And so others are just there to make accessing or processing or sending that data easier and more efficiently. So you can think about like databases, caches, even a lot of like CRUD kind of things we're doing is really just, or the endpoints are really just there to make the data that's in whatever its normal form is. Like maybe it's a file, maybe it's in your database. We're just making it easier to get at, right? That's what these endpoints are doing. And so hopefully it's easy to see kind of like the parallels between what factories are trying to do and what these servers are trying to do. And we're going to use these similarities in various use cases to great effect for understanding a lot of different scenarios in software land and how we can think about them based on our intuition of reality. Now, I will caveat that this is not a perfect metaphor. There's very few metaphors that are perfect. And in particular, we're flattening like what I call the four-dimensional world of software into a sparse 3D metaphor. So obviously there's some compression loss, but I think it can take us surprisingly far. So if you played any of these factory video games, I think you know what I'm talking about, where it's like actually building factories in 2 dimensions can be harder than 3 dimensions because you can't stack. So Mindustry or Dyson Sphere can be harder in some ways than things like Satisfactory because you can't build vertically. Satisfactory can be harder than things like actual programming because you are in fixed dimensions. I built this thing here. If I want to use that space, I can't, it's occupied. Whereas in software, a lot of times we can produce space by plugging in extra functions, by having middlewares, things like that. But obviously that's hard to intuit. We don't live in 4 dimensions. So end rant on that. Obviously it's a bit lossy compression, this metaphor, but I think it is still quite good for how easy it is to understand. Okay, on to factory actors. Okay, so with the factory as our stage, let's take a look at the actors we'll use to simulate this metaphor. And so here's a quick overview of all the actors that we're going to talk about. So we got, our factory and, this is the server. What else do we have? So we have loading docks. Like all factories need ways to get in. In our case, we only have loading docks. There's no other doors or windows or anything, just loading docks. Okay. Awful place to work, but we need this for the metaphor. And so on the server, this is going to be sockets or connections. This is how requests get into our server. And so the loading docks is the only way to get into our factory. And this is how we're going to get the payloads. This is how information is going to get in and out, stuff like that. Now we need things that actually do the work in our factory. And so these are going to be our workers. And server land, this is threads. And they're going to be the ones that are like fetching things. They're the ones putting things away. They're going to be the ones loading, unloading trucks. They're going to be the ones that are like creating the items from the other items. So they're the workers, but they have multi-potentiality based on what we tell them. They can do many jobs. And then we got our items. Our items are the actual things we're producing. So in factory land, this could be producing the nails, the screws, TV remotes, whatever it is we're producing. And then in server land, it's just going to be data, basically. We're all data. But you can imagine that like if you're doing software right and you're modeling right, like if you are producing screws, you do have a data that represents the screw. The software and the domain should always be as close to the same as possible, which we'll probably go into in a scenario later on with this metaphor. Now, finally, we've got trucks. And so this is a little weird, but we're just going to have to assume that trucks are the only way to pass information. We don't got phones, we don't got text messages, emails, we only got trucks. So we're back in the snail mail days, and the trucks always have some information on them. Like, let's say that there's like some information on what is this truck? Why is it here? What does it want? What is it trying to do? And then the trucks can have some amount of the items on them as well. And so in server land, this would be requests. You got your headers and whatever. It's the information that it's want, where's the URL it's going to, stuff like that. And then even some of this might be in the payload, but we'll gloss over that. And then it's got, maybe some data is on it that is its real payload. And so this is the metaphor from a high level. I'm going to dive into each of these in more detail as we go into each of them. But this is the metaphor. So as we mentioned, the factory, this is where all of our operations take place. For the factory, it's just a factory. Think about it like a warehouse, a factory. Use your intuition. It's got some space, probably contains some stuff, got, some raw materials stored. It's got some things it's created stored, stuff like that. And then there's workers inside of it that are doing the things. They're cleaning it up. They're moving the items. They're doing the work to make the stuff. Like, they're in the factory. They're doing things. It's a factory. Now, crucially, space is finite here, so we gotta somehow fit all our operations into the space or find other ways of doing things to, use our limited space efficiently. So this is a constraint that I think works very well across both domains and that we can play with a lot in many different scenarios. And so the server, server is a factory. It's what we've been talking about. And so everything is happening inside of it as well. So it's the same kind of thing. Like we got to get the data, we got to clean up, we got to make someone go do the actual creation of the items. And we still do have those space constraints. And again, this is the overlap of these two domains. And that's, again, in the number of workers, how we've set up the finite space we have to work efficiently, the number of loading docks we can handle for how many trucks and requests we can do at the same time, the amount of space to store things. All of these are the constraints that exist on both sides. Next thing is there's the items that we talked about. So these are the things we're processing. Might be one thing, might be many things. You can imagine that some factories are like really geared towards just like one kind of item. So they do them very efficiently, but a lot of factories, you're probably doing at least several items, maybe related items, kind of thing. And these are going to represent the inputs and outputs. As we're thinking about things, we can imagine that there might also be like intermediate parts, like, maybe you're building an electronic. You might have some stages where it's like, it's a half finished electronic that you store somewhere, so that when you want to build one, you just like, half of it's already done. So this will probably exist in a lot of scenarios. We'll gloss over it for now, but just know that's possible. And so in the factory, we can think of an item can be anything. So as we talked about, maybe it's nails for metal ore, or maybe it's just a warehouse that, stores things for the region so that you can come in and, let's say there's a Southeast warehouse, we have it so that when people order things from the Southeast, we get it to them faster as opposed to having to ship it across country or something like that. And so similarly for a server, it's, just a package of data. So maybe it's like, I don't know, an IG post and its metadata, like where do we get the picture? Where do we get the video? What, did you put as the comments on it? Stuff like that. Could be like an email. So every email you see in your inbox, that could be an item. Maybe it's a workout that you logged in your fitness app and you gotta, retrieve it later. Or maybe it's just the HTML for a web page. Like this one, we're assuming that this would be server-side rendered HTML. As I talk about in this post here. But you can imagine this data can be anything. Similar to an item in a factory, the data can be anything on the server. Okay, then we got our workers. So these are the actors who do the work in the factory. They're operating the loading docks. They're loading and unloading the trucks. They're going to be processing the items, creating the items, storing the items, moving the items around, all sorts of stuff like that. And based on the factory and configuration, we could have more workers. We could have less workers. These are options available to us. And so in factory land, this is often people, I guess, in the real world, but sometimes it's like robots. Whoever's doing this doesn't matter for our metaphor. What's crucial is that we're thinking of these workers as teachable. So they're capable of doing like multiple tasks based on instructions. And so they can really only do like one thing at a time, but we can teach them to do many different things. Kind of like a human, you'd expect a human to be able to do. Like that human can move the boxes, or they can load or unload the truck, or they can create the thing, assuming you've given them, sufficient instructions and training to be able to do that. And so they're not a hammer or a sewing machine that can only do one thing. They are like a person or robot that can do many things given instructions. And so in this metaphor, we're going to assume that they have instructions for how to handle tasks in the factory. And we'll talk about more about this a little bit later, but just know that, they have instructions and we can create those instructions and they can carry those instructions out. Now on the server land, a worker is a thread, and a thread is what picks up work and actually runs it according to its instructions. So very similar to a worker. The instructions are actually the software that you wrote. And so this is important, and why it's important to have this kind of distinction that they can do anything given instruction. Okay, trucks. This is the only mode of transportation or information passage that we have in our little factory land. It can carry 0 to many items. So a truck might have nothing in it, or it might have some information in it, or some kind of items in it. And always it has some sort of information to identify the truck, the items it carries, and its requests, what it wants. This is not strictly true in serverland, but I think it's close enough that we can kind of like hand wavy it. But it is important that everything is on a truck and that you can kind of like get the information out, the items out, stuff like that. Okay, so in factory land, a truck must be used to move items, or it could just be used to relay a message. So that's why you might have some trucks that have no items in it, but they might just be carrying some information. Crucially, we don't have alternative means of information relay, so like emails or text message. Everything must be delivered by truck for this metaphor to work. In serverland, this is basically just a request. Everything comes in a request. A request is like how you're interacting outside of the server bounds. And a request always contains information. Basically, we're not going to deal with edge cases. Always has information. Might have a payload, which is kind of like the items that it's containing. And based on the information, it can choose to do things based on the information it contains. Okay, last doctor we've got is the loading docks, and this is how we're connecting the truck and the factory. There are no doors in our factory, only loading docks. Each loading dock must be operated by a worker for it to operate. So it can't happen automatically. Got to be something they are doing work in order for it to actually operate. And for this metaphor, if there are no loading docks available, the truck either has to wait for one to be available, or it can just go away. It can give up. But if there's no loading docks available, it cannot, interact with our server. Okay, so in factory land, a truck must use a loading dock to connect to the factory. Regardless of whether it has a lot of items or no items, it still must use the loading dock. So there's no side door for just like relaying information. You got to use a loading dock. That's really important. And a worker will need to be present to operate the dock and receive the truck. The truck can't go if there's no loading docks available, and a truck can't go if there is a loading dock available and no worker available. So in server land, the truck is a request. So we're thinking about like an HTTP request. The loading dock is the connection socket on the server, and the worker is a thread. And so there must be an available socket and a thread to actually receive a request. And this means that our factory could be constrained by the available loading docks, but also by the available workers to operate them. And so this is very useful to think about as we're building our servers. And this actually, again, works very well across both domains of a factory and a server. Okay, so we talked about a lot of different actors in a metaphor, but where does the software fit in? Well, the software isn't really the server, so it makes sense it's not one of our actors. This is why system design and software design are similar, like they're affected by each other, but they're different. I think this trips a lot of people up, and so this is an important distinction here. So in our case, the software we're running on the server is actually the instructions we give to the actors in our factory, telling them what to do and how to do it. In factory land, you could think of it as the runbook for how each worker should do a task. And this is true. And like obviously in a real server, like software does have some overhead, like it might take up some space or something. But just imagine like if your workers are robots, maybe it's the little like mainframe server in the corner that takes up some space. But it's like directing everyone what to do, or maybe it's like the order room for humans where they like come to see what their next task is, or something like that. Obviously, if it's a server, we get into like a recursive, multi-dimensional recursive world. So let's not think about that. That's what it is. And so some things that we're using the software or the instructions to tell the workers to do is like, how do you create item X from item A? How do you create item B from item A? How do you load and unload a truck? Given a truck order, so you get the order from the truck, or the request from the truck, how do you find the items? How do you schedule them for delivery? And this is where the software comes into play, and like why it can be hard sometimes is you have many different options for doing all these things. How do you do them efficiently given the constraints of the server? And so we're going to explore a lot of different cases like this based on the server as a factory metaphor in the future. But for now, I just want to finish defining the factory here so we can use it in future videos. Okay. handling a simple request. With our server as a factory defined, let's run through a simple request to see how it works in practice. So for this example, we're going to just keep things very simple. The only thing we're trying to do is we got an item A and we're just trying to turn it into an item B. And I guess I'll just mention that like in server land, this is like the most common kind of thing, right? You send a request, you want to get some data back based on the request, which is essentially just A to B. And so this is basically what a request looks like, right? A request is going to come in on the truck. Let's say it's item A. We're going to get there. Then the worker is going to have to come and check the loading dock. Are you at the right place? Do we want to accept you? If so, we're going to like unload your payload. We're going to unload your item A. And then we're going to do some work on it. I don't know how we get to item A or item B. Let's assume there's some instruction set that allows for that. So it's going to take some time doing that stuff. And then we're going to get item B back based on whatever work we did. Then we got to serialize that, or we got to load the truck. And then the truck is going to go away to wherever it needed to go. And that's it. And so that is, the instruction set in factory land. And hopefully it's easy to see how like this is the same thing basically in server land. It's just that like when we're loading and unloading the truck, this is going to be a deserialization and serialization. When we're doing work here, it just might be on data instead of an item. In order for you to connect to our sockets, we need an open loading dock. In order for anything to actually happen, we also need a thread available to work the loading dock. It's like very, very similar, lots of overlap. And that's it. A simple request handled by our server as a factory. Next. Okay, so I've got a lot of ideas for different scenarios to leverage this metaphor in, but I wanted to share the metaphor out first to get feedback, and also because this is already a long video to explain the full metaphor. And so if I did this plus, explaining a scenario, it'd probably get like super long. So hopefully this is like small enough to understand. What I'm asking from you is, let me know if you like the metaphor. Let me know if you have suggestions for improving it. Let me know if you can think of any pitfalls, because I'm trying this out, seeing if we like it. And if we like it, we'll probably run through more scenarios like this. So if you like this post, you might also like a different metaphor, a mining metaphor. First, stop wasting your time on bad startup ideas. If you're interested in system design, you might be interested in software monoliths for scale. And if you're just interested in building your own server, so you like the factory metaphor, how do you actually build your own server? Might check out Build a Simple F# Web API with Giraffe. So that's it for this video. Thanks for watching, and I'll see you in the next one.